Okay, for question number 22, part B. So this is question number 22's part B. We have to find the value of lambda if the function is continuous. Now this function is continuous at x is equal to 0. So we can say that since given function or the function is continuous and function is continuous at x is equal to 0. So as this function is continuous at x is equal to 0 means that left hand limit should be equal to right hand limit should be equal to value of the function at 0 and value of the function at 0 is equal to 1. So these two will be equal. Let me take any one of the values. So let's say the left hand limit, I'm going to take the left hand limit. So let me equate left hand limit to the value of the function which is equal to 1. So now I'm going to find out the left hand limit. Let me find out the left hand limit means this limit is at x is equal to 0. So left hand limit will be written at x tends to 0 negative and value of the function. So when x is not equal to 0, function is this. So this is now limit x tends to 0 negative. Our function is sine square. So this is sine square lambda into x. So this is sine square lambda into x on x square. Okay, so let's try to solve this. Now we have we have to evaluate this the left hand limit, and to left hand limit let's take substitute. Let's say let be a small value h less in 0. Now we know that as it x tends to 0, h tends to 0. So let's replace the value here. So our limit is now in terms of limit h tends to 0. And instead of x, we are going to put this is sine square lambda. X is 0 minus h upon this is 0 minus h the whole square. So this becomes limit h tends to 0. So this sine square, this lambda, this becomes negative sine square lambda into h. And I can write this square. This is actually like this upon this is negative h square, which is h square. So this is now limit h tends to 0. So square of negative is positive, so I'm left with this is negative sine lambda h the whole square, so lambda square h square upon h square. Now let me multiply this with lambda square, and I can write it as, so this is limit h tends to 0. This is sine of lambda square h square upon, and let me write here lambda square, let me bring it here lambda square, and let me, so lambda square by lambda square, and let me write this h square into lambda square here upon h square. So lambda square and lambda square, and then h square into lambda square, and we have left with h square. Now we know that limit x tends to 0, sine of x by x is 1. So this becomes, that means when the angle is same, this becomes 1. So I can, if h tends to 0, so that means I can write this as limit lambda tends to 0. If lambda tends to 0, then sine square tends to 0. I can write it as sine lambda square by lambda square into this is limit h tends to 0. This gets cancelled and we are left with lambda square. Okay, this becomes 1. So this is 1 in our limit of h tends to 0. We don't have any variable h here. So this becomes lambda squared. Okay, so that means right hand limit would also be lambda square. So let me equate these. So the left hand limit is lambda square and value of f of 0 is 1. So lambda is equal to plus minus 1. So that is the value of the lambda that is equal to plus minus 1.